Have you ever searched for something in a database and known the result had to be there, but you just couldn't find it? Maybe you searched for a keyword like love, but missed results that clearly describe a romance simply because that exact word never appeared. This kind of problem shows up all the time when we search text, and it's a frustrating limitation of how most systems work today. In most relational databases, text search is still being done using keyword matching. The database checks whether the query word appears in the text, and if it doesn't, that entry is ignored. This is fine for some types of data, but not for natural language. Two pieces of text can be very similar in meaning, while sharing few or no exact words. As a result, relevant information can exist in a database, but remain hidden simply because the wording doesn't line up. My research explores how we can implement words numerically in a way that makes semantic meaning easier to compare. Instead of comparing strings of text to check for exact matches, we can represent words as high-dimensional vectors that encode how those words are used in context. With this representation, similarity isn't based on spelling anymore. It's based on meaning. This makes it possible to identify related words and concepts even when the phrasing is different. These vector representations are especially interesting because they allow us to do more than just compare words. They let us do arithmetic with them and observe patterns. Word vectors can be generated from many different types of texts, and they depend on the data they're trained on. They can reflect general language or very specific domains. The results of this project suggest that these representations can be used to support a type of fuzzy search, where users can retrieve relevant information without needing to query for the exact wording used in the data. To explore this idea in a practical setting, I applied these representations to a small movie database. Each movie's title and plot description were combined into a single vector that captures the overall theme of the movie. Those vectors could then be compared directly to individual word queries. This made it possible to retrieve movies based on conceptual similarity. For example, finding science fiction films when querying for a word like space, even if that word never appears explicitly in the movie's description. If you're interested in this approach to querying text by meaning rather than keywords, the full-length presentation goes into much more detail on the methods, results, and further. Thank you for watching.